Okay guys, in this lesson we'll learn how to generate caustics in V-Ray for 3ds Max using the caustics rollout under the GI tab in the render settings. The technical definition of caustics in optics is the envelope of light rays reflected or refracted by a curved surface or object, or the projection of that envelope of rays on another surface. In order to calculate the caustics effect, V-Ray uses a technique known as photon mapping. It is a two-pass technique. The first pass consists of shooting particles or photons from the light sources in the scene, tracing them as they bounce around the scene, and recording the places where the photons hit the object surfaces. The second pass is the final rendering, which is when the caustics are calculated by using density estimation techniques on the photon hits stored during the first pass. Now let's see what do we have in the scene. We have this curvy object which is going to be generating the caustics in the scene, and it has a blue refractive material applied to it. Right now we have two active lights in the scene. The main light that is coming from the right side and a fill light on the left side. And this is the render that we get from the current setup. There are a few steps we need to take in order to see some caustics in the scene. First, we need to go to the render settings window in the GI tab and caustics rollout, enable caustics, and this is going to be the first step. Next, in the material editor, select the material that is applied to your 3D object and make sure effect shadows is disabled. This is necessary to get physically accurate caustics. The next essential thing is a direct light source, either something like a sunlight or a directional area light. Let's try a directional area light. If I go to the perspective view, and this is basically our main light, and in order to make it generate some caustics, we need to make it a directional area light. If we try to increase the directional value under the rectangle disk rollout of the light, it would obviously affect the lighting in a way that is definitely not desirable for us, and most likely we want the lighting to stay the same. So we are not going to use this light as a caustic source or caustic generator. In fact, I'm going to select the light, right click and choose V-Ray properties and disable generate caustics for this light completely. Now this light can't generate any caustics. What I'm going to do is to select the light, right click in the scene explorer and choose clone as a copy and name the light V-Ray light underscore main underscore caustics. So you know this is the light responsible for generating caustics. Now press OK. Now right click on the light and make sure that this light is generating caustics. The next thing would be to make sure it is directional. So let's increase the directional value to 1. And to make sure that the light encompasses the entire object, I'm going to increase its size to 100 centimeters. Also, as we don't want this light to affect the lighting at all, in the options rollout, we can disable effect diffuse, effect specular, and effect reflections. So even though the light does not contribute anything to the lighting right now, but it still generates caustics. Let's get back to the camera view, and if we render the scene right now, we should get some caustics. When you render your scene with caustics, there is a pre-calculation phase to build the caustic photon map that's going to happen before the GI calculations. And the resulting render would be render 01 in the frame buffer right now. Now there are a few obvious problems with this render. It's very splotchy and also it's very bright. There are a few ways to control how bright the caustics are, and the first thing would be to decrease the overall intensity of the light. In this case, let's select the light and reduce its multiplier to 15 from 16. And the splotchiness is coming from the lack of enough traced photons. If I right click and go to the V-Ray properties for this light, we need to increase the caustic subdivs, which controls the amount of photons that V-Ray will trace to estimate caustics. Large numbers slow down the calculation of the caustics photon map and may take more memory. Now let's try a few caustic subdivs value and see what subdiv value can give us a good result. For the first render, caustic subdivs was set to 1500. As you can see, it's very splotchy. For the next render, it was set to 6000. Much better, less splotchiness, but more noise. And for the final render, it was set to 12,000. It's cleaner. We just have some high frequency noise that can be dealt with the image sampler. And as you can see, because the pre-pass phase to calculate the caustics has increased due to higher subdivs, the render time is higher for this image compared to the previous render. Now let's go to the caustics rollout, set the interface to advanced, and let's see what we have here. First, we have search distance, and this is the distance around a given shaded point in which V-Ray searches for the photons. Smaller values produce sharper but perhaps more noisy caustics. Larger values produce smoother but blurrier caustics. This value becomes less and less important as you increase the caustic subdivs of the light. So let's set the subdivs to a very low value like 75. And see how the search distance affects the caustics. In the first render, search distance was 1, then 5, and finally 50. As we increase the search distance, we get less noise and also less detail in the caustics. Let's set the search distance to 5 again. Next, we have max photon, which is the maximum number of photons to be used inside the search distance. Smaller values result in a sharper but noisier result, and higher values produce smoother but blurrier results. Now let's set the caustic subdivision of the light to 6000 and try different max photon values. In the first render, max photon was set to 10, then 60, and finally 120. And by increasing the max photon each time, we get blurrier, smoother, and less detailed results. Let's set it to its default of 60. Multiplier value controls the strength of the effect on a global level. So if you have a few caustic generator lights in the scene, this value affects all of them. And if you want to control this multiplier on a per light basis, simply select the light and right click in the viewport and go to the V-Ray properties, and under generate caustics section, you can adjust this light's caustic multiplier. In this case, let's do it globally and take a look at a few renders. In the first render, multiplier was set to 1. In the second one, it was set to 2. And finally, it was set to 4. And obviously, each time we increase the multiplier value, we are going to get stronger caustics. Let's set the multiplier to 1 for now. Next, we have max density, and let me quote V-Ray guide for this. Max density limits the resolution and thus the memory of the caustics photon map. Whenever V-Ray needs to store a new photon in the caustics photon map, it will first check if there are any other photons within a distance specified by max density. If there is already a suitable photon in the map, V-Ray will just add the energy of the new photon to the one in the map. Otherwise, V-Ray will store the new photon in the photon map. Using this option allows you to shoot many photons and thus get smoother results while keeping the size of the caustic photon map manageable. In the next render, I set the max density to 0.1 and the light caustic subdivs to 18,000. And now we get this smooth and noise-free render, which it would have been very hard for the memory to manage a subdivision of 18,000 without using a max density higher than 0. And max density normally should be kept very low. For now, let's set the max density to 0 and caustic subdivision of the light to 6,000. We have direct visualization, and if I enable it and render the scene, we can see the calculation of the caustic photon map. Let me stop the render and disable it for now. We have mode, which controls the mode of the caustic photon map. When set to new map, a new photon map will be generated. It will overwrite any previous photon maps left over from previous rendering. When set to from file, V-Ray will not compute the photon map but will load it from a file. You can use this browse button to specify that file. And save to file saves out an already generated photon map in a file that you can later on load it using the from file mode and skip the calculation of the caustics map before rendering the final image. So when your render is finished, you can simply click this save to file and save the caustics and change the mode to from file and load this file that you've just saved and render your scene without regenerating the caustics each time. We have don't delete, which if enabled, the photon map in memory after the rendering will be kept, otherwise the map will be deleted. We have autosave. When enabled, V-Ray will automatically save the caustics photon map to the provided file when rendering is complete. And switch to saved map. This is only available if autosave is on. It will cause V-Ray to automatically set the mode to from file with the file name of the newly saved map. And if you right click on any object in the scene and choose V-Ray properties, you get some caustics related options. We have generate caustics. This option needs to be enabled so when the caustic generator light hit the object, the caustics can be actually produced. We have received caustics, whether the object receives caustics generated in the scene by other objects or not, and caustics multiplier, which is a multiplier for the caustics received by the selected object. And for the final render, maybe let's set the caustic subdivisions for the light to 18,000. Set the max density to something like 0.07. We can possibly use a lower max photon number like 40, 30 to get a bit sharp result, but I'll leave that to you. Let's add a V-Ray denoiser pass and set its preset to mild. And in the comment tab, set the resolution to 1280 by 720. In the V-Ray tab, set the image sampler to bucket, max subdivs to 24, and noise threshold to 0.008, and render the scene. In the frame buffer, this is our final render. Let's check out the denoiser pass as well. You see, beautiful and clean. In this lesson, we learned about caustics in V-Ray. See you in the next lesson.